Guys, welcome to the channel. Today we're going to be going through some trigonometry, exam style trigonometry questions. And before I get started, guys, as usual, if you find value in these videos, make sure to like, subscribe, share, comment, set the notification bell on. Really helps the channel. Appreciate all the support, guys. And also, as much as you show support, also show criticism if you find any. That way I can improve and give you guys more value. But make sure to nonetheless share with your friends on WhatsApp groups, Facebook, Instagram, wherever you guys are at the moment, just so we can spread this content as far and wide as possible. So without further ado, guys, let's get started. So okay, showing all necessary working, solve the equation cot theta plus 45 degrees is equal to 2. All right, now what is cot? Cot is 1 over 10. Okay, so therefore what I can say, guys, is I can say fine, 1 over 10 theta plus 1 over 10 theta plus 45. Okay, remember we're working in degrees here. That's going to equal 2. All right, and so I could then say the following. Well, if we've got this is a compound angle, I know that tan A plus B is equal to tan A plus tan B, okay, over 1 minus tan A tan B. All right, cool. And so what does this mean? Well, what this means, guys, is if we plug in theta plus 45 into here, we get tan theta plus tan 45 over 1 minus tan theta tan 45. So we can flip that around now. So what we get is 1 over tan theta plus 1 minus tan 45 tan theta over tan theta plus tan 45. Right, now what that equals then is going to be 2. Okay, brilliant. So we take it from there. What does tan 45 equal? Well, tan 45 equals 1, guys. So what we get is 1 over tan theta plus 1 minus tan theta over tan theta plus 1. Okay, and that's going to give me 2. From which I can now say the following. What we've got here is our common factors. So I've got tan theta plus 1, okay, plus tan theta 1 minus tan theta, okay, is going to equal 2 tan theta plus 1. Okay, cool. So what we're going to get is tan theta plus 1 plus tan theta minus tan squared theta is equal to 2 tan squared theta plus 2 tan theta. Okay, so I've got tan theta here, plus tan theta. Okay, so we got 2 tan theta minus tan squared theta plus 1 is equal to 2 tan squared theta plus 2 tan theta. Okay, now what we're going to do, guys, is we are going to eliminate these because they're going to cancel each other out. Okay, and so what we're going to get then is 1 is equal to 3 tan squared theta. Okay, which therefore means that tan squared theta is going to equal 1/3. Right, so tan theta is therefore equal to 1 over root 3. Perfect. And actually plus minus. So now, guys, we've got two options. we've got tan theta is equal to 1 over root 3, or tan theta is equal to negative 1 over root 3. In this case, theta is going to equal 30 degrees. And in this case, theta is going to equal negative 30 degrees. Now what happens here? Well, what happens here, guys, is if I get the cast diagram, okay, and we've got 180 plus theta, what I can say is the following, okay? Firstly, I can say that theta is equal to 30 degrees. Okay. Now remember, it's between 0 and 180. Okay. So theta is equal to 30 degrees. But theta cannot equal 180 plus 30 is equal to 210 degrees. That's not going to happen. Okay. Why? Because it's outside of the period. But when we've got negative 30 degrees, we can get a bit creative, because I can just put it here to pretend, and then 180 now plus negative 30 is equal to 150 degrees. Okay, because I've basically put this in negative 30 here, the all is positive section, even though it's not actually positive. I just kind of plugged it in there, okay, to give me 150. The other way to think about it is to say, the other way to think about this, guys, is basically to do this. You could instead, for negative 30 degrees, you could instead go, okay, instead of having this, you could have it here where tan is negative, and you could apply it like that, but keep theta as, so obviously that's going to be 180 minus theta, 360 minus theta, but now in this case with negative 30 degrees, you keep that as just 30 degrees. You're not going to acknowledge the minus. You're just going to acknowledge it being positive to 30 degrees, and then you get 150 from here. But I like to think about it like this, simply because it's easy for me to conceptualize. So that's going to be our two answers, guys. So theta is going to equal 30 degrees, or theta is going to equal 150 degrees. Right, guys, now question 2. Okay, question 2 wants us to show that this is true. Okay. 2 sine x minus 2 sine 2x over 1 minus cos 2x is equal to sine x over 1 plus cos x. How do we show that? Well, I'm going to say this, fine. For I'm going to say this, okay? I'm going to say left hand side. Okay. 2 sine x minus sine 2x over 1 minus cos 2x. Okay. Now, what's that the same as saying? Well, what that's the same as saying, guys, is 2 sine x minus 2 sine x cosine x. Okay, because I'm going to put it on the screen now. The formula. Okay. That's 2 sine x cosine x over what? 1 minus sorry, wait. Cos 2x minus 2 x. Okay. Cool. So this is what we've got when we simplify it out, which is going to give us what? It's going to give us 2 sine x minus 2 sine x cosine of x over 1 minus 1, 0 plus a 2 sine x. So we've got 2 sine squared x here. Cool. And now, as you can see, we've got a common factor of sine x. So what can I say? Well, actually 2 sine x. So I can take out 2 sine x here. I've got 1 minus cosine x at the top. Okay. And that's over sine squared x. Well, that's actually going to simplify out even further. Okay. Because the 2 is going to cancel. And that's going to turn into just sine x. So what we've got then, guys, is 1 minus cos x. Okay. Over 1 minus cos x over sine x. Okay. And actually, wait. Hang on. I'll reverse that a little bit here. See, this is what happens. You need to keep an eye out on things. And when you realize you're going down the wrong path, you can quickly adjust. So what I'm actually going to say here, guys, is I'm still going to take out the 2. Okay. I'm still going to take out the 2. I'm going to take out the 2 sine x over here. So I've got 1 minus cosine x. But I'm going to change things around a little bit. Because I'm going to turn this into 1 minus cos squared x. Okay. Aha. Yes. So, once I've done this, what's going to happen? The 2 is going to cancel. Now what I'm left with is sine x 1 minus cos x over 1 minus cos squared x. Now you might be thinking, well, fine, this is a dead end. What do we do from here? Well, now what we're going to do is we're going to use the difference of 2 squares. Okay, we're going to use the difference of 2 squares to give us sine x 1 minus cos x over 1 minus cos x 1 plus cos x. Because these are all products, I could then cancel these, which leaves me with what? Sine x over 1 plus cos x. Okay, so I can therefore say that, therefore, left-hand side is the same as right-hand side as required. Okay, guys, so that is going to be our final answer. Now, how do we do that? We started off on left-hand side. Okay, start off on the left-hand side, and we basically just went through it. Simplifying this out. Okay, and simplifying this one out. Getting it into a form that we can then say, okay, we can take up 2 sine x, and then we apply difference of 2 squares here. Okay, effectively turning it into a product so we can show that left-hand side is equal to the right-hand side. And that's how we did that one. Alright, guys, now for II. Okay, so we've done I over here, but for II they want us to do the following. Find this integral in the form of ln k. Now, at first glance, this integral looks quite unappealing, to say the least. It doesn't seem very open, receptive, not something that's going to be very easy to solve. But luckily, we've worked out that this here is the same thing as this. Okay, so all we have to do is actually plug this in for this, which greatly simplifies the integral here. So actually what we've got is the integral of pi over 2 and pi over 3. Okay. and it's going to be sine x over 1 plus cosine x dx. Alright, now remember, the first hint here is actually ln k. Remember that when we've got f dash of x over f of x, it's going to equal ln of f of x, okay? Now here, we know that d dx cosine k is equal to negative sine x, okay? And so we've got sine x at the top but not negative. So what can we do here? Well, what we can do is we can say that we've got minus sine x here, cosine dx. What this means is the negative, if we multiply the integral by -1, and we just put a negative in here, we've technically times by 1, which is the same thing, okay, but we've put it in a form where we can solve this equation. Remember, these are going to cancel because negative times a negative is equal to 1. So it's exactly the same. This is exactly the same thing as this. Okay, but so we've just put it in a form that we can actually solve for. And so what this is actually going to give us now is ln of 1 plus cosine x, okay, between pi over 2 and, sorry, pi over 3 over here on the bottom. Okay, cool. So we've got negative ln of 1 plus cos of pi over 2 minus ln of 1 plus cosine pi over 3. Okay, cool. And so what's that going to give us? Well, what that gives us, guys, is we now have negative ln of 1 plus cosine pi over 2 plus ln of 1 plus cosine pi over 3. Alright. And so, we can now say the following. Well, what is cosine of pi over 2? Well, cosine of pi over 2 is, well, 0. So negative 1 plus 0 plus ln of 1 plus cosine of pi over 3. Well, that's just a half. Okay. And so what do we get? Negative ln 1, ln 1, 0. And then we get ln of 3 over 2, 1.5, 3 over 2. So that's the same thing as saying ln of 3 over 2. And so, guys, what we've done is we have solved this question accordingly. Because what we've got here is we've got this equation, and what we've done is we've solved it. We've changed the form, and we've solved it quite easily. Okay, so that'll be the final answer, guys. Alright, guys, now question 3. Okay, it says, showing all necessary workings, solve the following equation. Alright, well, let's take a look at what we got here. Right, so we've got sine theta minus 30 degrees plus cos theta is equal to 2 sine theta. Cool. Between 0, theta, 180 degrees. Okay. Now, we just have to expand this now, okay? So using the compound angle formula that you see on the screen now, what we can say is sine theta times cos 30 degrees minus cos theta times sine of 30 degrees plus cosine theta is going to equal 2 sine theta. Okay, so what we can therefore say, guys, is root 3 over 2 sine theta, okay, minus a half cosine theta, okay, plus cosine theta is equal to 2 sine theta. Perfect. So from here, what can I say? Well, let me think. Boom, boom, boom. Right. Okay. Right. So, what I'm going to do is multiply by the common denominator, which is 2 on the bottom. So what we get is root 3 sine theta minus cosine theta, okay, plus 2 cos theta is equal to 4 sine theta, okay, which means what? Means we've got root 3 sine theta minus 4 sine theta minus cos theta plus 2 cos theta is equal to 0. Okay, so we minus the 4 here. So that means what we got is root 3 minus 4 sine theta plus cos theta is equal to 0. Okay. Cool. And so guys, what we get is root 3 minus 4 sine theta is equal to negative cosine theta. Okay, so root 3 minus 4 is equal to negative cosine theta sine theta. Okay, and here's what we can do. We can actually flip this around. Okay, if we were to flip this around, we could then say that tan theta is equal to negative 1 over root 3 minus 4. Okay, because think about it. You times both by, this is equal to 1 over tan theta basically. Okay, then if you multiply tan theta there, and then divide 1 by this, etc., you get this. And so, what can we say? Well, what are we solving for first off? We're solving degrees, okay? So, theta in this case is going to equal, if I just get my calculator up. Okay, get my scientific calculator. Body tan. Okay, 1 over root 3 minus 4. Okay, that's going to give me, let me see here. It's going to give me 23.7 degrees, sorry. So we get 23.7.8 degrees actually. Okay. Now we see what we got here. Okay. 3.8. Okay, but in this region, so 180 plus theta is going to be out of bounds. Okay. So this is going to be our final answer, guys. Alright guys, now for question 4, guys, it's just a case of saying, well, listen, We want to solve this equation, so let's start with cot 2 theta is equal to 2 tan theta, which then tells me that 1 over tan theta is equal to 2 tan theta. Now remember that tan 2 theta, let me write this in red. Remember that tan 2 theta is equal to what? Tan 2 theta is equal to 2 tan theta over 1 minus tan squared theta. Okay? Which means that 1 over tan 2 theta is equal to 1 minus tan squared theta over 2 tan theta. Okay, so taking that now, we can say the following. That 1 minus tan squared theta over 2 tan theta is equal to 2 tan theta. Brilliant. So what can I say from here? Well, what I can say from here, guys, is that 1 minus tan squared theta is then equal to 4 tan squared theta. And what we're going to get from here is an equation. We can say that 5 tan squared theta then is equal to 1, which tells me that tan squared theta is equal to a fifth, and so tan theta is plus minus 1 over root 5. Okay, brilliant. And so what do we get from here? Well, what we get from here now, we can say the following. So if we take tan theta is equal to 1 over root 5, if I plug that into my calculator, we're going to get 1 over root 5 2 seconds. That's going to equal 24 degrees. Okay, so theta then is going to equal 24, actually more precisely 24.1 degrees. Okay, if we're taking it to 1 decimal place. Now if I draw my cast diagram now, we're going to get the following. Okay, we've got 24.1 degrees here, right? And over here, so tan is positive as well, but this is 180, 180 plus, okay, theta. Now, what does this mean? Well, in this case, guys, I mean, we're not going to be able to get an answer of, so we've got theta is equal to 24.1, firstly. Okay. But if you remember that we could also get the following. So what we can also get is theta to equal tan of negative root 5. Okay, now that's going to give me negative 24.1 degrees. However, that's out of bounds, right? That being said, if we do 180 plus, okay, so if we take negative 24.1 as this angle here, we do 180 plus negative 1, 180 plus negative 24.1, that's going to give me 155.9 degrees, okay? And so from here we can say that we solve the equation, okay, because what we've effectively done is used both of our angles here to then solve the equation for those angles.